We're recording. All right, so improper integrals. It's a technique for handling what is an improper integral? An improper integral is an integral. Okay, how about I write it a different way? How about I say an integral is improper? I'm trying to get this so it doesn't sound horrible. Don't ever play this for Miss Busconi. An integral is improper. That's better. That's more better English. If what? One, either limit of integration is infinite. Meaning it's going to be negative infinity or infinity. 2, there is a discontinuity in the interval. And it doesn't matter what kind, because what we're going to do is, suppose there's a hole. We're going to handle it by just removing the hole. If it's an asymptote, suppose there's something that has an asymptote right smack dab in the middle. Imagine, so we have some curve. So imagine we have a curve that has an asymptote right in the middle. So I have it like this, and there's an asymptote right here, and it does like this, and I want the area in the first curve, in the first quadrant. Actually, we'll make it cross actually, like so. So there's a definite area, right? Well, how do I find that? This thing is, it's going to get infinitely close, right? So imagine that I have this region here, and I just take one of those X-Acto knives and cut right here. What if I just, because that's infinitely thin, right? What if I just slice it out? Does it have any impact on the value of this area or this area? If I just slice it out? Do we all agree that if I have an integral, suppose this is going from 0 to b, if I have the integral of some function f of x from 0 to b dx, do we all agree that I can integrate to some, this will be some a value? What can I integrate from 0 to a of f of x dx plus the integral from a to b of f of x dx? Can I break that into regions? Right? And what if instead of having it go to actually a, what if I just have it do a limit and it goes right up to a? It doesn't ever get there. I'm just going to do a limit. It doesn't have to get there, does it? So the way we handle this is we're just going to slice it out. We're going to break it into 2 regions, and then where the offending party is, we're going to take a limit there. We're going to make it go right up to it but not get there. And by slicing out the asymptote, I haven't removed any area because it's infinitely tiny. I haven't removed anything, but I've handled it properly. So why are we doing this? Because to have correct notation for the ones that have asymptotes and holes and jumps in the middle, we have to say that we're going to take away that so that we can find the area between over the whole interval. Where this technique comes in handy is for the ones that are going like in the first quadrant and it goes to infinity, to know whether that area is going to converge or not. That's how we're going to handle this, because you're not sure. The question is, whenever you got one where, so for instance, you know how there's the exponential function? What does the exponential function look like? So it looks like this, right? Well, what if I do the negative? So exponential of a negative value. So it's 1 over exponential function. What does it look like? Do you know what it looks like? There it goes, like this. Oops, sorry, I didn't do that very well. It does like that. And the question is it getting small enough, fast enough to converge to a specific area in the first quadrant? So is this getting small enough so that if I do a limit as x approaches infinity, I'll actually get a value? That's the question we're asking here. And this is the technique to handle it. And the best thing, let me just show you some examples, and I'll explain it as we go along. We're going to use limits again. So we're going to just integrate things, integrate functions, and then we're going to use limits to evaluate them to see if they're actually going to converge to a specific value or if it's just going to infinity. If it's going to infinity or negative infinity, doesn't converge, doesn't exist, right? But if it approaches 0 fast enough, we're going to get a specific value for area. So that's our essential question. Is it converging? Is this converging? Is f of x converging or approaching? How much about we say approaching 0 fast enough to converge? I'll say fast enough for the area to converge to a value, not infinity or negative infinity. So with that in mind, we'll start our first example. Example 1. Find the area in the first quadrant for f of x equal to e to the negative x over 2. That's why I'm doing this example. So does it look something like the e to the negative e to the x? I mean, e to the negative x, only it's going to go down a little different? Yes. So let's see what this happens. So if we're trying to find area, we are going to integrate from 0 to infinity of that function e to the negative x over 2 dx. Now, if I just did an improper integral, you could integrate that, right? Using u sub? Sure you could. But because it's improper, as soon as you see this, it's improper, and you have to use a limit to evaluate it. If you just go do the calculus without using the correct notation on the free response question, that's the only time this is going to appear on the AP test, then you won't get full credit. For me, even if I did a multiple choice question on this, if you don't write down the correct notation to show how you handle an improper integral, because I'm going to ask for that. You know how on the multiple choice I ask for, like, write the integral, write the first step? If you don't write it correctly, you don't get credit. So how do we write this correctly? We have to do a limit. And notice this is kind of A and that's B. We're going to say B, our limit of integration B is going to infinity. And we're integrating from 0 to B of e to the negative x over 2 dx. So just ignoring this limit right here. Have we done this kind of integration before? Is that the second fundamental? Well, it's not. Is this the first fundamental theorem of calculus where we're just plugging in a value? We've done this. Remember when we wanted a specific equation for the position, and you put x up there, and you integrated and put x in, and you had remember the future value problems? You've done this, only it's b instead of x. Okay, you have done it. We'll see. To do this, I can do it without it, but for you, what would you pick u to be? Right? U equals negative x over 2 du equals negative 1/2 dx. I don't have the half there, so what does that mean? It means I have negative 2 du equals dx. So this becomes negative 2 du. This becomes u. Do my limits of integration change? They would. But here's what we're going to do. When we get to this point in time, you're just going to know, I'm going to go do an indefinite integral, and then I'll come back when I get to the limits. We want to come back to x's. I don't want to have to fiddle with plugging in those, because b is a limit. I don't want to fiddle with it. Do you understand what I'm saying? I'm always going to come back to the x's. You can do what you want, but I'm going to come back to x's. So I'm going to go off here to the side. I'm going to go, okay, I have the integral of e to the u, negative 2 out in front, du. What's in it? What's its integral? Negative 2e to the u plus c, but I'm not worried about the plus c. I'm doing it indefinite, right? Do we all agree? So is that going to be, we'll say plus c for right now. Negative 2e to the negative x over 2. Agreed? So what does this become? This becomes the limit as b approaches infinity. My antiderivative is negative 2e to the negative x over 2, and I'm evaluating from 0 to b. So you see what I did? I did a u sub, but I didn't do a complete u sub because it's I don't want to fiddle with b because it's a limit. Yeah? It's a little complicated. Okay, I need another page. I'm gonna take this with me. I'm gonna copy it. Ooh, look at me. Ooh, ah. Oh, I didn't mean to cut it. Paste. Hang on. Where did it paste to? Oh. I didn't mean to do that. Okay, back here. Copy. That's what I want. Next page. Next page. Paste. Ooh, ah. Look at all the stuff I've learned to do. Aren't you all proud of me? Look at all what I'm learning. Okay, so we got this back, yeah? All right, we got it back. Now we're going to evaluate this thing. So what does it equal? Oh, I got to get back to my draw. This equals, evaluate that. So I have limit as b goes to infinity of, put in b, it's negative 2e to the negative b over 2. Put in 0, minus 2e to the 0 power. Well, what's anything to the 0 power? That goes to 1, so this whole term goes to negative 2 times 1, so it's just negative 2, yeah? Everybody see that? This would be a plus? Yeah, because it's net, you're right, because I'm supposed to be subtracting. It was already a negative 2. So it's plus 2. Get rid of that. It's plus 2, because this thing's 1. All right, do a limit as this goes to infinity. Let's rewrite this so it makes it easier on you. I have the limit as b goes to infinity of negative 2 over e to the b over 2. I wrote it this way on purpose because as this, what happens to the exponential function as the power goes to infinity? Is this going to go to infinity? Yeah. You are dividing by infinity. What's this going to go to? The whole thing going to go to? 0. Agreed? Hang on, I'm not done yet. I forgot the, hang on, whoa. I didn't, wait, I didn't write the other part. Get rid of this, get rid of this. There's the 0. Did the plus, this is a 2 because we just showed that that goes to 2, so I have 0 plus 2 is 2. Does that area converge? Wow, who'd have thunk it converged to 2? It means that it's getting small enough, fast enough that it actually converges to a value. If you add a half, start at 1 and add a half of that, 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 is it going to converge to a specific value? No, because it's not getting small enough, fast enough. Just saying, it's not. Some things converge, some things don't. Okay, so that's how you handle limits of integration. That was just one. When we started with this, what did we start with? We started with one limit of integration was infinity. Right? What happens if it's more than one OMG, Mrs. White, what are you doing to us? So let's go through all the scenarios, because I can have negative infinity, positive infinity, or both. I can. So we have, here are your choices. If we have a to infinity, we just did that one, f of x, that's one form. The other choice is to have negative infinity to b of f of x dx, so b is some number. Or I could have from negative infinity to infinity of f of x dx. We have to handle these properly and show the correct notation. Or they think we don't know what we're doing and we don't get any points on our free response questions. That would suck. So each time do you go find where there's a problem and replace that with a letter and have a limit. This one's interesting. For this first one, we just replace that with a b, right? So we're going to do a limit as the b limit of integration goes to infinity of the integral from a to b of f of x dx. So am I just taking a limit on the upper limit of integration and doing this the first fundamental theorem of calculus? So you're just using the first fundamental theorem of calculus and a limit. For this one, my a is the one that's unbounded, so I'm going to say the limit of a approaching infinity of a to the b of f of x dx. Do I really care what letter you pick? No, I'm just saying. It is. I'm just using, the a is always the lower boundary, the b is the upper, so I tend to use a for the negative infinity, b for the positive infinity. I just tend to do that. For this one, can we break that up into two intervals? Can we go from negative infinity to 0 and 0 to infinity? So is it this one going to 0 and this one coming from 0? Does that make sense? Actually, this one going to 0 and this one coming from 0. Does that make sense? Oh, let's see. Let's put it all together. For this one, it's going to be the limit as a approaches negative infinity of a to 0 of f of x dx, and it's going to be plus the limit as b goes to infinity. I didn't write that right still. I said it, but I didn't write it right. Of the integral from 0 to b of f of x dx. So when I give you the infinity to negative infinity, is it just two problems put together? Boy, won't that be fun.
Why doesn't it work for the squared one that Ashley integrated that process? Because you take a double integral, you square it.
Hang on. Can I finish this first before we go diverge off into something else? Before we lose everybody, I haven't even got them yet. We'll look at it afterwards, okay? All right. So let's try one of those. Example 2. Do I have enough room? Yeah, I have enough room. Sam, did everybody copy that? The patterns? You got the 3 patterns. It's this one, or this one. For now. Don't worry. Eventually we're going to have asymptotes in the middle, and we're going to have our limits in the middle. But not right now. Whoo! Here we go. So for this one, I want example 2 to be, I want some area. I'm gonna go ahead and write the integral. I want the area under e to the x, period. Did y'all hear me? These are the words that go with it. Tell me the area under the function e to the x. That means I have to go from negative infinity to infinity of e to the x dx. Is that going to converge? Intuitively, do you think it's going to converge? What does e to the x look like? Is it going to converge? No, but how do we show it with the correct calculus notation and show that it diverges? Here's how. So we're going to break this up. We're going to break it up into from negative infinity to 0 of e to the x dx plus the integral from 0 to infinity of e to the x dx. And then we're going to write it, so area equals, for this one we're going to do the limit as a approaches negative, oh, I say it and I don't write it, negative infinity of the integral from a to 0 of e to the x dx. And then we're going to add the limit as b approaches infinity of the integral from 0 to b of e to the x dx. What's the integral of e to the x? So now I have the limit as a goes to negative infinity of the integral, of e to the x, that's my antiderivative, evaluated from a to 0, plus the limit as b approaches infinity of e to the x evaluated from 0 to b. So that means I'm taking the limit of a going to negative infinity of e to the 0 minus e to the a. For this one, I'm doing the limit of b going to infinity of e to the b minus e to the 0. So one part's going to converge and one's not going to converge. Let's see what happens. What's e to the 0? That's 1. Okay, this means that I'm going to have, so as this goes to negative infinity, does that mean that this is going to 1 over e to the infinity, just for talking purposes? So what's that going to go to? It's going to go 0, right? Let me write this a little bigger here. This is going to 1 over, because it's a negative, e to the infinity, right? E to the negative infinity is 1 over e to the infinity. Does this whole thing go to 0? Right? Because we're dividing by infinity. So is this thing going to be 1? That one converged. That part converged. So from negative infinity to 0 converges. But from 0 to infinity does not. Why? Because this is going to go to infinity. What is e, as x goes to infinity, what does e to the x go to? Infinity. So as it goes to infinity, this diverges. So therefore, area diverges. Because that interval does not exist because we are going to infinity, right? Because infinity plus 1 is just infinity. Yes? Agreed? Okay. So the ones with limits of integration that are in infinity or negative infinity are obvious. You can't have a limit of integration that's infinity or negative infinity, put in a limit. The ones where it's not defined at a place are harder for y'all because y'all don't remember any algebra 2, or you're going to have to work at this. Here's my example 3. If I have my area is equal to the integral from 0 to 1 of 1 over x to the cube root of dx, do you need to look for asymptotes? Is 1 over x to the 1/3 power defined at 0? Can you have division by 0? Is that a vertical asymptote? So do we have an issue right here? There's a vertical asymptote there. I cannot have x equal to 0. That is the biggest one. Your denominator can't be 0. So look in the denominator for these. If either of those limits of integration or anything in that interval, I could have gone from -1 to 1 and I still would have had a problem at 0, right? So look for where there is a vertical asymptote or a hole or any kind of discontinuity. And I have to get rid of that. So how do I do that? I do a one-sided limit. Everything you forgot about limits is back. So I'm going to do a limit. This is my lower one, so I go a from the is going to approach 0 from the positive side. Can I get right up to 0, but I can't go to 0, correct? Agreed? And I'm going to go the integral from a to 1 of 1 over x to the 1/3 power. Can I just change that to x to the negative 1/3 power dx? Is that an easy integral? Have you already done it? Probably for me you have. So let's do limit of a approaching 0 from the positive side. What is the antiderivative of x to the negative 1/3 power? X to the what? What's the new power? 2/3 times, well, divided by 3/2, which is times, 3 over 2. Divided by 2/3 is times 3/2. I can do it, I can't say it. Whew. And I'm evaluating from a to 1. So what does my area equal? It equals the limit as a approaches 0 from the positive side of 3/2, and that's just going to become 1 to the 2/3 power, which is just 3/2, right? Minus 3/2 a to the 2/3 power. Right? What's this going to go to? As a approaches 0, what's this approach? 0. It's going to approach 0, so what does this equal? Oh my goodness, it converged. So in reality what's happening is all I did was take an X-Acto knife and slice off that vertical asymptote. And by slicing off the very edge of that area, did I impact the value? No. I just got rid of the thing that blew up. I have one more example. Oh, I know, don't groan at me. Example 4. Y'all are so pathetic. Why am I doing so many examples? Because y'all won't see this unless I beat you over the head and shoulders with it. Because it's algebra. Okay. Uh-oh. Does x ever equal 0 here? I mean, does the denominator equal 0? If I have x minus 1 equal to 0, x equals 1 is a vertical asymptote, right? So I cannot have x cannot equal 1. Is that in that interval? Do we have an asymptote right somewhere between? Can I break it up into 2 intervals and slice off the offending vertical asymptote? Do y'all see what I am going to do? Yep, I'm going to do it. I am going to take the limit as b approaches 1 from the negative side. Now, okay, so I have this region. If I'm approaching from this side, so I have some vertical asymptote I'm going to cut off, right? Is this from the left side? And then do I have to have another one that's coming from the right side? Do you understand what I'm getting at? If my vertical asymptote is at 1, do I have to have a left side and a right side limit? So this is the left side. Do we all agree that if I go from, because I'm going from 0, if I go from 0 to the vertical asymptote, which is 1, do I need to come from the left side and not ever get there? Do we agree that 0 is on the left of it? So it's 1. So does this become just x minus 1 to the negative 2/3 power when I go to integrate? And then am I going to add the limit as as a approaches 1 from the positive side, and it's going to be a to 3 of x minus 1 negative 2/3 dx. My asymptote was at 1 right here. I had the problem right there, right? It's between 0 and 3. So I'm going to go from 0 to right up to the asymptote, but I'm going to come from the left. I'm not going to get there. And then I'm going to jump on the other side of it, just to the right of it, and go to 3. Well, these two areas add up to the total area, and all I've done is take out and sliced out that infinitely narrow strip that's undefined. okay, let's do this. We're just doing limits. So is that an easy thing to integrate? Add 1 to the power. What's the new power? X minus 1 to the 1/3 power, right? I'm doing limit as b approaches -1. And I'm evaluating from 0 to b. And did I forget to do something? I'm dividing by 1/3, so I'm multiplying by 3. Agreed? And then is it plus the limit as, so that's supposed to be, this is b. B. I'm going from 0 to 1. Then I'm doing the limit as a approaches 1 from, okay, that's supposed to be 1 from the negative side. This is 1 from the positive side of, is it the same antiderivative? Evaluating from a to 3. From 0 right up to, but not getting to the asymptote, from the asymptote to 3, we're going to evaluate it. So my area is equal to, we're going to plug those back in, right? So it's going to be the limit as b approaches 1 from the negative side of 3 times b minus 1 to the 1/3 power minus 3 times 0 minus 1 to the 1/3 power plus the limit as a approaches 1 from the positive side of the same thing, but I've got 0 and 3 and a going in. So it's going to be 3 times 3 minus 1 to the 1/3 power minus 3 times a minus 1 to the 1/3 power. And we just look at it. As b goes to 1 from the negative side, is that just essentially 0? Is that going to go to 0? Agreed? Now what's this go to? 0. So what am I left with? I'm left with 3 times 1 to the negative 1/3 power. Was that -1? What's -1 times -3? 3. For this one, it's going to become 2 to the 1/3 power. So is this plus 3 times 2 to the 1/3 power? Is that just the cube root of 2? And is that my answer? So is that what the area converges to? Oh, what a hot mess. Notation matters. That is what's going to hang you up. Are you going to have to practice this? Yes, you are.